We're going to talk about a new, I would call it blueprint that we're building for Transition Manager, which is called TMDB. And really what it is, it's a migration modernization factory blueprint. One of the things you're going to learn about over time about Transition Manager is super, super flexible, which can make it, I would say a complex configuration event, depending on how complex your scenario is. What we're doing to kind of take away that, I would call it pain, is we've instantiated a methodology and a model for how to do modernizations, and it's going to look very familiar to you. Which, if you think of our strategy for the DMA team, we wanted a model, we wanted a factory in place for doing modernizations. We wanted to be able to understand the state of those deliverables throughout the migration process. We wanted to understand where the constraints were, where the bottlenecks were, so we could improve our mechanisms to accelerate migrations and reduce customer pain and time to get to a scenario where they could get rid of their expensive Oracle and SQL licenses. Transition Manager, as I said, is enterprise orchestration software. It essentially, it can ingest data from multiple sources. It can ingest data from SCT. It could ingest data from Jira. It could ingest data from Excel, from Microsoft Project, and many other sources. And when we get to the chaos slide, you're going to see why that's super valuable. And if you think about it, on these complex migration projects, there were many, many different parts of the organization that needed to be involved, whether it was the infrastructure team to provision the infrastructure we needed to do our work, whether it was the security team, right? Whether it was the team that provisioned access to their databases, and all along the way, we would be asking for access to everything, and those teams were blocking us, and it would delay our ability to execute on a schedule that we thought was reasonable, because there's delays and bottlenecks throughout that whole process. Transition Manager really addresses those problems and brings a ton of visibility to it at whatever level you want to target the communication during execution of a project. For example, we had bi-weekly reviews with our group vice president and the GMs. We could do that review in Transition Manager with real live data. We don't have to go to PowerPoint. We don't have to generate Excel spreadsheets and snap them into PowerPoint. You can do it all in the tool. We could do the weekly review, which is more detail and understanding what needs to be done at more of the daily project level. And you could even use this tool for stand-up, as long as we had data from, for example, Jira updated, and our development team was actually using Jira to do those updates. Whether it's in Jira, GitHub, doesn't matter. We can ingest the data and have one logical view of that entire project in one place. As I mentioned before we got started today, that Transition Managers had a great partner strategy, and it's becoming more and more prevalent with their current go-to-market strategy. And you can kind of see these are big names. In fact, we were talking to several of these guys in the DMA partner program. And these guys are very interested, of course, in doing migrations to the cloud. They're also very interested in doing modernization, which we'll talk about in a minute. But what they're seeing, this is what the data is showing us: 65% reduction in FTE resources. And you can think of, like, I'll go to Sean, how many different project managers were trying to manage parts of this project, of the project you and I were on? At last count, I was at about 4 that I could identify. What if you had all that data real time instead of everybody coming up with their own view of the data, so that we could try to stay in sync? 70% improvement in project delays, getting rid of those project delays, and a 35% reduction in project duration for migrations. That's something that we believed, and I know with Brent and everybody else, the whole notion of building out that factory was that was one of the key reasons. And with those reductions, you're going to see reductions in cost, and net you're going to see acceleration to cloud service consumption. The product's been out there for quite a long time, and there's a lot of customers that have successful cloud migrations that have used TransitionManager, and there is a configuration for lift and shift. And you can kind of see the customer names are pretty impressive. What's more impressive than that is that they've got an 89 net promoter score. And just, I think everybody knows, but net promoter score is how likely would you recommend, how likely would you be to recommend TransitionManager to one of your friends and colleagues that needs to use it? And 89% is super high. Siloed data, it's impossible to manage, and we know, all of you know this. You know, we've taken data out of SCT. We've built project plans in Microsoft Project. We've, you know, done dependency mapping with, you know, what is it, Modelize IT. We've done TCO analysis with DBOla and third parties, and you know, we've done, you know, project tracking and status in Jira, and none of this data is integrated. Yet it's all about the same project that we're trying to execute on. This is what TransitionManager addresses in a first-class way. So let's go ahead and move on. Uncovering dependencies. I mean, I remember, Peter, you and I on a certain project, the customer guaranteed us we had 4 schemas in that database, and we ended up with 14. And that was after we had to do more analysis from what they told us. We've seen the skills and experience gap in almost every engagement I was involved with at AWS. The orchestration problem is prevalent everywhere because there's no way to integrate those teams and bring visibility to execution. And this complexity from a time to value perspective, and when I say time to value, I'm talking about the customer. The customer's time to value means the shorter their project duration, the faster their time to value. And I can tell you that modernization can take a long time, which all of you know. And if we can find ways to accelerate that, which is, I think, that's the central value of DMA and what we tried to accomplish and have accomplished in many cases. Rework, you know, the longer those projects takes, the more rework we're going to run into. And we know the business is going to change. But if we had visibility into what the business was doing think of the IT team that's doing feature development, and we had visibility to it during our planning process, we could avoid rework by staging our waves or parts of the actual migration in the wave we're in a very thoughtful way, which we, you know, Sean, we had to do, right? We had to really get down and work hard to get that alignment with the business IT team to make sure that we had that alignment so that we didn't end up with a ton of rework. And then the testing problem, right, is that functional testing is challenging because a lot of users lack having enough test coverage and it's not automated. And so it creates this technical debt during the migration that we have to go after. Otherwise, we could end up with a dumpster fire when we try to go into production. So the vision we've got is, hey, we're going to provide our customers and partners with a pre-configured migration modernization factory blueprint to improve efficiency, decrease risk and cost, and simply enable a faster and smarter transition to the cloud. And this is about modernizations. It's not, you know, we have a solution for lift and shift. Now it's all about modernization and accelerating that. So to make this happen, how we're doing this is we're extending TransitionManager from, you know, lift and shift scenarios to modernization. We're essentially going to accelerate those adoptions for customers by delivering these blueprints. Think of them as it's pre-configured transition manager with proven modernization methodology, practices, and persona-based reporting. Meaning that if we have a meeting with the steering committee meeting, we can target that view of a dashboard so that it's ready to go for that particular persona. Or it could be, a bi-weekly meeting, or it could be just the solution architect that wants to see, hey, how are we at in post-SCT? How many objects were actually auto-converted? How many are remaining? And that can be where they can live to understand that. They can also use it for dependency mapping. We're going to get into the demo. We'll take a look at that. But this is actually a dashboard inside of Transition Manager. Now, it's not exactly where we need it to be, but that's part of the dialogue that we can have to you to say, let's get the exact information that you need to make this view absolutely what you would want to go look at if you're trying to understand the state of a migration. And there's all sorts of data that needed to be ingested to generate this particular view, which is what we do. There's a lot of existing API, or I would call them data extracts and ingestion that we're doing with a lot of other products out there already.
So Let me set the stage a little bit for the story we're telling here. So this is, Acme Corp is moving out of a data center. They're doing a data center evacuation. Their main charter is make sure to get out of the data center within the year or within a year. But they also have an initiative to move Oracle to Postgres as well, and move like Oracle to RDS, Oracle to Aurora. And so we're looking for opportunities to do some of those activities in parallel, and also to take command and control of the whole project as one. And so Transition Manager breaks up into 3 modules. We call them Insight, ability to understand your entire IT environment and make data-driven decisions. Orchestrate, which is then creating repeatable processes in an industrialized migration factory, optimizing that automation along the way. And then Accelerate. So we have APIs driven to different tools. So we can even demonstrate for you here how we would stand up the containers in AWS, the database containers and CloudFormation templates, mixing human and manual tasks together. So putting human gates on, but then passing those configurations over to AWS. And then we go through and continue to optimize that way. And so in this example, we've come up with this waves, but how did we get there? And so if we go through and look at my database and discovery dashboard, so the story here is that we've ingested data for the full environment from many different sources, Modelize IT, from vCenter exports, from RV tool scans, from many different sources. And then we started to sweat and analyze that data. And so we said, okay, we want to go after some Oracle databases. So we discovered those 600, we found 300 Oracle databases. And so now we're looking at all these Oracle databases. And so we're going to go through and say, out of these Oracle databases, we want to go through and see which ones are candidates to modernize, right? So we're going to come up with their candidacy, and we're going to come up with how they fit within it based on some criteria, their compatibility, their business value, and their complexity. And so we're going to go through.
Before you jump this, the complexity, business value, those particular, I would call them columns or attributes, we don't pre-configure those as for customers at scale with one configuration. That's something that is determined within each project. Is that correct, Dan?
Correct. So in this case, what I'll show you is how they gave us what their decision criteria was for creating migration patterns. And in this case, it was based on these. And so how they're coming up with business value is they're using Modelize IT data, they're using Cloudimize data, and we're basically taking a few data points and ingesting and coming up with a common score Some of it might be even driven from some of their own cost models. And then we're taking that all, so what's their maintenance cost, their hosting cost, operating cost, and what would it be from a sizing on AWS, and then rolling that all up, all automated through our ETL scripting process to these business values. And so just to give you a snapshot of what that looks like, on that ETL scripting process, we keep lots of different scripts available, and that's part of how we'll take in the data and keep that cadence, so we always can trust the data from all these different sources. And then we can also assess the data. So in this case, we've pushed the databases out through SCT or through Cortex to do the assessments, and that's coming up with our complexity. But we'll go through here and we'll say, okay, and so we've built that logic into the tool, and you said, okay, based on those, tell me what the recommended migration paths should be. And so we take a scripted approach, which again, this is tailored per the decision tree the client gave us. And we said, go ahead and assess all these databases and tell us, what path they should take. And in this case, we're going to give them a migration path of lift and shift. Hybrid is going to be your 2-put, and modernize is what we're going to look for in either 1-put, or we'll just move to EC2 and do the conversion there. And so you can see it automatically takes. So if you think about what just happened there, we just took about 14 data sources, analyzed all the data, married it all together, and then applied decision criteria and organized it all. And then we went through and said, okay, and this is a conversation Mike and I really got into, is the first charter is that we are doing a data center evacuation. So the way we approached this is, instead of just going after, the Cat 1s, we said, let's come up with the event schedule. Let's come up with the cutover event schedule. It's going to be based on maintenance windows available, and it's going to be, organized based on bandwidth capacity. And so we came up with these, 10 events. And now what we're going to do is look for, within those events, where is our high business value and low complexity to start, right? And so that will give us a good sense of, what do we want to start with? And you can see some Cat 2s, Cat 3s. And so just kind of playing this story forward for a second, and then I'll pause. We can see that, okay, we've got, I'm going to use, event 2 as an example. So we've got a group of databases. There's some Cat 1s, some Cat 2s, and they're all within this cutover event. And so we're going to go through and grab some of those and say, okay, what do we need to do with this? And if you think about through the lens that this also exists through the whole data center evacuation. So now when I'm looking at that same modernization group, I'm seeing how it fits within that overall project, right? So what are the dependencies to this? How are these events going? And that's where, when I really dive into the event 2 here, I can see, all right, well, I've got some of those Cat 2s, Cat 1s, and a couple Cat 3s, and I can now plan around the whole piece so that we're going to move them. And what we're basically going to do is modernize along the same schedule, so we're ready for that event to cut over. So what we're seeing, I'll pull up my legend for you here, is that we are looking at, these are some of the databases, like the one I just highlighted. So we have, if we actually look at this database, so we have, this database, and we have what its dependencies are. We're tracking all these different pieces in here, and we're getting all this data from SCT, Cortex, rolling it all up, and then how it's interacting the whole environment. And that's part of how so we know this database, if we're going to take it to AWS, it needs to live within the same cluster. And so we need to treat them as a group accordingly.
What we want to be able to do is give the architect the ability to persist the future state architect, well, 2 things, the current state architecture that was discovered in the discovery and assessment phase, and the future state architecture that we're trying to drive towards for a specific database application, group, our wave. And so what that would look like from a transition manager perspective is we would want to, persist those, call it final architectural diagrams, and serve them up through Transition Manager, most likely via link to where it was managed from a source control perspective.
The way we look at modeling this now is, source and target, it's really what is in production. And so this database, would be running on-prem right now. And so to your point, what we do is we'd actually clone this record. And so we'd have a mirror of it showing it being staged in AWS. I was trying to pull it up. We actually have this in here, but I seem to have lost which record that was. And then, so instead of running on EC2, and we show it as a future state dependency. And so then when we actually go through and do the modernization, we'll then change the dependency so it becomes the now production. Because an important, fact is there's going to actually be two databases for some point in time, because you're going to need to decommission the old one. And so we'd actually manage the process of decommissioning the old cluster, and we would manage the process of optimizing the new cluster on the target. You can see that, we have, for the ones we were just looking at, wave 2, we have that they'll also go into a cutover event, that they'll also go into a failover event once they reach AWS on the target. And then we'll also start to see, different streams being managed to go through and do the decommissioning and the optimization. And that's kind of leading to the next functionality here, where if we go through, there's a modernization phase. And so here is going to be my modernization for wave 2. And here's everything that's going on in the modernization phase. But if you saw, as I pulled that up, we have lots of other type of activities going on at the same time. And so you'd have that optimize and tune. And so what's happening here is this is a codified way to generate all of the tasks based on the data and the metadata and the criteria that involves here. So for instance, if we know that this is a Cat 2 and we know it's going to have 2 cycles of tuning and have a conversion with it, it's going to auto apply and come up with what we call our task graph. And so this is kind of, I'm just giving you a high level, but it's kind of a large concept of that you're going to have these things auto-generated for lots of different examples that come up with, here's your critical path, and it's going to manage the whole process. And so that's part of how we're creating that repeatable industrialized process, is that we're always tuning that as we go through and analyze what were the steps. And we'll give you an example of that.
So if we do an Oracle to Postgres modernization, and there are other services that we're going to need to leverage as part of that, if we have that future architectural requirement, does Transition Manager help us make sure we provision the right infrastructure to make that happen?
And let me give you an example of that. So, if we're going through and we're in a fix and tune phase, right, we can now see what's happening, and we can see that the project is falling behind here. And so the story we're telling, and it's a powerful one, is that, okay, we're hitting all these errors, things aren't working right. We're tracking, we're getting from Jira, these guys are falling behind. And in the end, we find out the issue was that the golden copy had been compromised. And so we, have gone through and, we've isolated the issue, but now it's going to send our project off on schedule because we basically need to go do and redo things. So we're going to do 2 things here, right? So for one, everyone is command and control of that. We now know that, and we know we can fix the golden copy. And so if we go back to how we're generating those tasks automatically, so remember, this is looking at the criteria of the database, generating the path for it. We're going to add a step into this to auto-generate, to basically log the golden copy, the version that was taken, the date, who passed it. So we have that benchmarked. We're going to add that as a step into the process. And so it'll happen every time going forward. So I always say, fool me once, shame on me, but you're not going to fool me twice. But the thing that Mike was drawn to here too, and we went through this is, okay, so this is now, we're behind schedule. We're going to miss this maintenance window. And so, we fixed the problem. It's not going to happen again, but we don't want to lose that maintenance window. And so what we're going to do is we're just going to go ahead and grab some of the items from cutover 4 and lift and shift, and we're going to basically horse trade, this cutover 2 and allow us to finish those modernization exercises. We're going to grab a bunch of things from cutover 4 because remember, we have it already bundled. We know all the dependencies. We know things that we're ready to lift and shift over. They just, weren't prioritized for the bandwidth window. And we're going to push this through. So we're going to keep this project on schedule. And this is something that regularly happens in the real world to us all the time. So what we also do is that we've gone through and we've codified all these pieces. We actually start to codify, and we've already done. So on our standing up the landing zone, kind of show how we take those provisions and configurations. And this is something that we're very proud of, that we can hand off those CloudFormation templates. So, what size EC2, what size RDS do we need? All of the criteria that would go into, standing these up. And we can automate that process. So we relieve the issue of human errors of copying and pasting. And what we've seen in the server world is because we bring such an efficiency, when we first started doing, server migrations, people get excited about doing 20 at a time. We automated it to the point that we'll move hundreds and hundreds of servers in an event. We moved 10,000 VMs to AWS in 6 months for one of large banks. And this is how we did it. We just automated, industrialized the process, and just kept looking for ways to speed up. And we can do the same in the database space.
I mean, our integration framework, again, is completely flexible. And, essentially what we can do is any task that's in a workflow, we can attach a unit of automation to it called an action. And under the hood here, it's simply just PowerShell, right? And that gives me the flexibility to parameterize and pass information to endpoints to do a unit of work. So whether I'm using TransitionManager as a repository, it has its own ability to store code and deal with merging and executing code. I can also wrap calls to other endpoints to external systems and bring those all into one workflow. So if I'm using a customer Git, if they give me access to it programmatically, I can unify that into this runbook and use their source code, right? And pass information to it, right? That it might need, to kick off infrastructure as code, right? As an example. It's a hybrid approach. We're taking the decision from a tool like a Cloudimize or a Modernization that's trying to right size a workload, based on historic performance usage, right? And we take that under consideration, but then we're able to layer that with the customer's decision tree, right? I don't want to run N5 extra large in this reason because it's not available, right? And we're able to kind of add more metadata and more of the business factors around that but to answer your question, it's taking the tool's output, but also enriching it with other customer constraints and data points that we're bringing in from other places. And we can make a decision based on many factors.